I will solve this problem, planet gears, with using relative motion. So what is the data that is given? We have that the angular velocity of gear D is in negative direction, so it's negative 5 radians over second. That means that it's rotating in this way. And then we have the angular velocity of the link BC, which is 4 radians per second. So that one is this one right here. And we like to find the angular velocity of gear R, which is this one right here. So we have gear D, gear A, link BC, and then we have the point B, which is a fixed point, C, which is rotating with the link BC and the gear A, and this is unknown. Okay, so I'm going to do the solution using relative velocity. So to do that, I need the velocity of 2 points of the gear R. I'm going to name this point P, and I'm going to name this point S. So I have to use the data that is given to find the velocity of these 2 points. So first I'm going to use a system fixed at the origin at B, fixed at gear D. With that, I will be able to find the velocity of P, which is the velocity of B plus angular velocity of D, and is given that is in negative k, right? I just put k, and when I substitute, I will put negative 5, cross the distance, and the distance will be the distance from from P to B. Okay, so we know that the B is a fixed point, therefore we have here negative 5k cross. From B to P is negative 150 I, therefore from here we get the velocity of P, which is equals to 750. K times I is J, and with negative and negative give me a positive value. I can do exactly the same to find the velocity of point E, which is the point between those two gears, and the velocity of E will be the same velocity of B plus omega D cross velocity now from E to B, and that will be equals to negative 5k. Now I have 150 I, therefore the velocity of E is equals to negative 750 J meters over second. So if we draw this gear D, this is point B, and the velocity of P is that one, velocity of P, and velocity of E is that one. And B has zero velocity. Now we want to find the velocity of C to be able to do the analysis of gear A. So we will fix also a coordinate system in B, but now fixed to link BC. So the velocity of C, which is the center of the gear A, will be equals to the velocity of B, again is 0, plus now we have the angular velocity where we fix our coordinate system, which will be BC cross the distance between C and B. Now substituting the values, we have that the angular velocity is 4k cross the distance between B and C, and it's 150 plus 75, this everything in I, right? Therefore, the velocity of C is equals to 900 millimeters over second. Now, we are going to do the analysis of gear A. So I'm going to fix a system at point C, which is the center of gear A, fixed to gear A. And since I want to find the angular velocity of that gear, I will use a point of known velocity. And since these 2 points touch, so these two velocities are equal. So I can say that the velocity of E, which is known, will be equals to velocity C, that is also known, angular velocity of A cross the distance of E respect to C. And then from here we have that the velocity of E is equals to negative 750 J equals to 900 J plus angular velocity of A in K cross the distance, which is negative 75 I. So K times I is J, negative J. So from here I can solve for angular velocity of A, and I get that is 22 radians over second. So with the angular velocity of that gear, we using the same coordinate system, we will find the velocity of S, which equals to the linear velocity of C, which is known, plus angular velocity of A, and now is the distance from S relative to C. And then we have that's equals to velocity of S will be equals to velocity of C plus 22 in K cross 75 in I. Therefore, the velocity of S, let me put this in vector, the velocity of X is equals to 2550 J millimeters over second. So if we would draw the gear A, we would have that we have the velocity of E the velocity of S, C, and the velocity of S. Okay, so finally we already have a velocity for point S and a velocity point P. Therefore, we will have a system, for example, fixed at P, fixed to gear R. And then we have the velocity of S, with the other point that we know the velocity is equals to velocity of P plus angular velocity of R cross the distance between S and P. That will be equals to the velocity of S, we just found it, the velocity of P, we have it right here at the beginning, this one right here. Then is 750 J plus velocity of R in K cross the distance will be 150 plus 150 plus 75 plus 75, that's 450 I. So all those values are positive, so I solve for angular velocity of R, and I get that this angular velocity is 4 radians over second. And that's the result we were looking for. This one right here. So Just to review what we did, we fixed system to each of the body, and we always use, wherever we fix our system, that was our angular velocity. Here is BC, here is A, and here is R. And those angular velocities are always absolute.